In this video, we are asked to solve by the elimination method. We don't have a word problem, we just have a math problem to practice our skills. So we know that the elimination method involves strategically multiplying so that one variable will add to 0. So when I look at the coefficients in front of the x, I could see that I could strategically multiply and they could both be 12. I would actually want one of them to be positive 12 and one negative 12 so that they would add to 0. I could also look at this problem and the strategically multiply idea, and I could pick a totally different approach that would still work. So I could look at the y values and I could say, ooh, 3 times 11, that would be 33. So I could make them both be 33. And again, I would want one to be positive and one to be negative, but I already had a positive and a negative. So I could multiply them both by a positive number. This is one of the really cool things about doing these types of problems. Both strategies will work. It's just a matter of what you feel most comfortable with. So for this example, I'm going to do the problem using the first idea of making them both 12. So I'm going to take out this idea of making them both 33, even though that would work equally as well. And for some of us, we would actually prefer that because we would not have to use the negative. So if I'm using the first strategy, give me a moment while I try to get my pen back. There we go. I'm going to pick to multiply this entire first equation by a positive 3. And that's because 3 times 4 would give me 12. And I'm going to pick to multiply this entire second equation by negative 4. And that's because negative 4 times 3 would give me a negative 12. Remember that when I'm doing this, I need to distribute. So first thing I get is 12x. Then I need to multiply by the y value here, so plus 9y. And then I need to multiply over across the equals too. So equals 78. Now I'll do the same thing with this second equation. So I multiply the first two terms and I get a negative 12x. That's exactly what I wanted. So those will strategically add up to 0. But I gotta finish the problem. Multiply here. 2 negatives make a positive, so I have positive 44y. And multiply across the equals as well. And again, 2 negatives make a positive, and so I have positive 28. So put my equal sign, put my addition. The first two terms cancel each other. They add up to 0, which is exactly what we wanted. So our next two terms add up to 53y. Keep my equals lined up. And my last two terms add up to 106. So divide by 53. And I get y is equal to 2. Now I do have to go back and figure out what the x value is. And so I will use substitution. And we can do this with either equation. Does not matter at all. I'm going to pick the first one because it is first. So I have 4x plus 3, and I substitute in my y value of 2 equals 26. Now I can do the math. So 4x plus 6, doing that multiplication, equals 26. Subtract 6 on both sides, and that gives us 4x equals 20. divide by 4 on both sides, and we get x is equal to 5. And so we have both the x and y value, and we have truly solved the system of equations by the elimination method.